Will we find extraterrestrial life before GTA 6? The James Webb Telescope has confirmed that molecules exist in the atmosphere of the exoplanet K2-18b that are produced exclusively by living organisms on Earth. Astronomers say that this is by far the strongest evidence of extraterrestrial life we have found so far, and that this alien world could even be teeming with inhabitants. If this groundbreaking assumption is confirmed, it would be nothing less than the greatest sensation in the history of space exploration. But what exactly are the signs of life that K2-18b has given off? What do we know about this planet? And could it be that it has already produced beings that are technologically far superior to us? Be sure to stay tuned until the end to find out all the details of this exciting discovery. It's a question that's probably as old as humanity itself. Are we alone in the universe? Could it really be that Earth is the only celestial body in the entire cosmos that has paved the way for life? It certainly cannot be said that we haven't tried to attract attention to ourselves. After all, we have repeatedly attempted to send messages to extraterrestrials with the Voyager Golden Records and the Pioneer plaques. But unfortunately, the hoped-for response has not yet come. Fortunately, however, we are not completely doomed to twiddle our thumbs and wait. With technological marvels, such as the James Webb Space Telescope, we are now able to actively search for extraterrestrial signs of life. While one of the main tasks of the $10 billion device is to search for the oldest luminous objects and galaxies in the cosmos, Webb is also focusing its sharp infrared gaze on the atmospheres of exoplanets to investigate their potential habitability. And in fact, the most powerful space telescope ever built has already scored a remarkable hit in 2023, a hit that goes by the name of K2-18b, located about 124 light-years from Earth. Basically, this planet, about 2.6 times the radius of Earth, not only moves in the habitable zone of its star, but is also suspected of being a Hycean world, covered by a global ocean. And since water in its permanently liquid form is, to our understanding, a fundamental pillar for the development of Earth-like life, experts hoped to uncover a red-hot lead there. That's exactly what Webb did. K2-18b made headlines 2 years ago when Webb found the first signs of dimethyl sulfide here, a sulfur compound that was immediately discussed as a potential biosignature of extraterrestrial organisms. And that was no coincidence, of course. After all, dimethyl sulfide DMS is produced exclusively by living organisms on our planet. We simply do not know of any abiotic synthesis pathway by which this molecule could be produced. But what exactly is DMS? To understand this, we need to take a little detour to the beach. DMS is produced by marine plankton during the decomposition of organic substances. It's also responsible, among other things, for the typical smell of the sea air. Returning from the sea to the vast expanse of space, however, we realize that Webb's discovery in 2023 had a major drawback. On one hand, the DMS signal from K2-18b was not particularly strong. On the other, it was only detectable when the data was analyzed in a very specific way. This is because the potential biosignature was identified by Webb's near-infrared spectrometer, NIR spec, which unfortunately overlapped strongly with a methane signal, making it difficult to separate the two molecules. The researchers later discovered in their models that, under certain conditions, biogenic sulfur gases can indeed accumulate to detectable concentrations on hydrogen-rich planets. But that was only theory. In order to put K2-18b to the test, a new investigation by the James Webb Telescope was essential. This time, Webb did not use NIR spec, but rather the MIRI spectrometer, which uncovered something that could mark an absolute turning point in astronomical research. Have we just discovered extraterrestrial life? While the spectral line detected by NIR spec was visible at a wavelength of 3.4 microns, MIRI operates in the mid-infrared range, between 6 and 12 microns. And this is crucial. On paper, DMS and several other potential biosignature gases should produce even clearer signals in this wavelength range than in the near-infrared. And indeed, Webb's recent analysis revealed clear peaks between 6.8 to 8 microns and 9 to 11 microns. Subsequent comparison with the expected spectral lines for 20 different molecules showed that there is no doubt that the signatures must come from DMS and or DMDS, dimethyl disulfide. Nikku Madhusudhan from the University of Cambridge, who led the study, said, "Our data confirm the clear presence of only two molecules, DMS and DMDS. Even more decisive is the high significance of the observation. The bottom line? The probability that the spectral signature actually originates from DMS or DMDS is 3.2 standard deviations this time. That corresponds to a 99.7% probability that it's not due to coincidence or measurement error. In other words, we now know of a celestial body whose atmosphere is 99.7% likely to contain gases that, on Earth, are produced only by life. Even more surprising is that the concentration of DMS on K2-18b is over 10 parts per million, which is 1,000 times higher than Earth's. Madhusudhan explains, these amounts indicate very strong biological activity on the planet. This is consistent with what has been predicted for such high-sea worlds, and that is exactly what we have now observed. Given what we know so far, the ocean of this water world could be teeming with life. Why experts remain cautious. So, can we finally put the alien question to rest? Has the question of whether we are alone in the universe been answered once and for all? Well, not quite yet. Leading researchers emphasize that a single measurement is not concrete proof. As Madhusudhan puts it, it's important that we remain deeply skeptical of our own results. Only through repeated verification can we be certain. That's how science works. Webb's observation does not yet have official discovery status. That would require reaching 5 sigma significance, a probability of 99.9999%. However, this threshold could be reached soon, with only 8 to 24 more hours of additional observation time during transits of K2-18b. Even if DMS and DMDS are confirmed beyond doubt, that alone is not enough. Although on Earth these molecules are produced only by life, we cannot yet rule out the possibility that an abiotic process may exist elsewhere. In fact, some scientists are skeptical. David Kipping from Columbia University reminds us that DMS has also been found on comets. Meanwhile, other researchers suggest that K2-18b may not be a water world at all, but rather a magma-covered furnace. As study author Christopher Glenn puts it, nothing is proven until ET waves at us. And before we wave goodbye, don't forget to like, subscribe, and click that bell icon to never miss another cosmic discovery. We'll see you soon. Alien Globe Showing Europe Africa.